If anyone wants them, that's where they are. Okay. Hello, he says, talking into the void. Thanks for inviting me. It's nice to be here virtually. I was getting more and more terrified the more maps that Kevin was showing of how many people potentially are out there listening. But, you know, who knows? There's probably only 2 people and a cat actually there. Who knows? So I'm going to start the day. So today's all about what works. And I'm going to start it on a depressing note with a talk called Damnation and Deliverance. And it's Opeth themed because they're an amazing band. So the first thing I'm going to talk about is the heritage. Why are we teaching statistics and why is it important and why it matters? I've got some solemn music for that particular theme. So why is statistics important? We actually do, I think, one of the most important jobs of anyone for our students, especially in psychology, because I believe very firmly that statistics is a really important life skill. And what we are giving our students, arguably, is more use to them in life than what they're learning in psychology. Some of my colleagues might disagree, but they're wrong. So there's an interesting paper, actually, it's quite old now, but that talks about why a statistics education is useful in life. So things like you learn about when causal relationships can and can't be inferred. You learn things like the difference between a statistically significant effect and a practically important effect. I think most important, you learn about sources of bias in experiments, surveys, research, stuff like that. And most important, I think, in some ways, is you learn about variability being normal. And this really hit. So I've used this example a lot, but this really hit home to me when I became a parent, because if you're a parent, you have lots of experiences like this of falling apart when they're learning to walk. And you can get very caught up in this idea of, like, you know, other people's children are more developed than my children. And, you know, why is it, you know, Jane from the nursery can sprint down the road, our son is still backing it every time he tries to move his legs. And this can be quite a source of anxiety. But fortunately, learning about statistics enabled me to negotiate those early years by thinking, well, variability is normal. It's fine that all the other children are reciting Shakespeare in his nursery. He'll get there at some point. Very common, you know, phrase or conversation between my wife and I was, she would say something like, do you think that's normal? And I'd say, well, it's on the normal curve. At which point she would roll her eyes and start Googling divorce lawyers. Another example of why statistics is a useful life skill. Here's so first lesson about teaching is update your examples more often than me, because I dragged this out and realized it's a really old example. This is from a UK newspaper from about 2006. And it was all about how the contraceptive pill can ruin your sex drive permanently. So here are some quotes from that article. So yeah, it's very scaremongery. I'm trying to find a scaremongery line. Oh, it's something about permanency. Oh yeah. So new research suggests the effect on libido might be long-lasting or even permanent. So it's very, very scaremongery article. And I had a lecture where I used a few examples and I actually kind of dug up the research. So this is the paper that this article is referring to that had these kind of headlines. And it was basically a study looking at people on the contraceptive pill who come off the contraceptive pill. And they were measuring this thing called SHBG, which in theory correlates with libido, but it's not actually a direct measure. It's just a sort of physiological thing that correlates with it. And so their conclusions, I mean, basically what the study shows in a nutshell is if you're on the pill, levels of this thing are high, and if you stay on the pill, they stay high. If you're not on the pill, levels of SHBG are low, and they stay low. If you're on the pill and you come off of it, levels of that thing are high, but they go down. Like, it's not that surprising, really. So most of what this article headline is all about is this gap here. So people who've come off the contraceptive pill and comparing them to people who were never on it in the first place. And yeah, basically, if you're kind of like really dig in to this article, so if you are someone with a statistics education training, if you're someone who's gone to do psychology but had the horror of having to do research methods for 2 years instead, you can kind of like rewrite these newspaper headlines. So all the stuff in the sort of orange font is like if you like, Psych student copy editor changing these quotes from the paper. So the paper starts off saying women may suffer a permanent decline in sex drive, and actually it's not a general population study. It was done in a sexual dysfunction clinic. It's not permanent. They basically measured people on average about 3 to 6 months. There were some who were followed up as much as a year later, but on average it was 3 to 6 months. So that's not permanent, is it? It's not very permanent at all. Like there's lots of claims in here about the effects on libido. And like I said, they didn't measure libido. They never measured subjective libido at all. And they only ever measured this thing that in theory correlates with libido. And, and meeting with expectations, levels of this hormone did decline, but just, maybe not quite to the levels of people who are not on the pill. But then there's some kind of ridiculous things where they quote that levels of this hormone were 7 times higher, and there's nowhere in this paper I can find this value of 7. I think it must be like a maximum, like the maximum difference was 7, because otherwise I have no idea where it comes from, because the kind of group level effect was 5, not 7. But I don't know, maybe the Daily Mail lives in a parallel universe where 7 is actually 5. I've got no idea. And also that effect of 7 times more was actually at baseline before the people had come off the pill, so which isn't made clear in the article. Then if you look at the effect that I highlighted, so the effect that is kind of at the core of this newspaper article, again, they're talking about effects being 3 to 4 times higher. But again, this must be a maximum effect, because if you look at the group level effect, it's more like 2. So it's kind of grossly exaggerated. The other thing that they fail to mention is that the women who discontinued taking the pill were followed up for a much shorter period of time than the never users. So you're kind of comparing apples and pears there. So had the discontinued group been followed up the extra 38 days later, then maybe the levels you might expect would be lower. So basically, you can, statistics gives you the power to read. I'm sorry, I'm being very conscious of my language, of reading through some of the fake news. That's the word for it these days, isn't it? Fake news. That's the polite way to put it. So what are the problems that we face when we Well, I think a big problem, especially in psychology, which is the discipline that I work in, is we get 600 undergraduates every year coming into our university, all very, very excited that they're going to learn psychology and discover themselves. And what they discover instead is 2 years worth of statistics, which maybe wasn't what they're anticipating discovering. So I always feel a bit like the kind of Pied Piper who is leading the innocent psychology students away from the cozy village of psychology and into the hillside of statistics, where they will all perish. So, we're kind of facing an uphill struggle right from the beginning, I think it's fair to say. If you look at the literature, the things that people generally talk about as being barriers to learning on the kind of student side, actually some of these have already been mentioned: self-efficacy or lack of it. A lot of breadth in the cohorts of students in terms of ability and backgrounds and what they know coming into the degree. Anxiety is always getting mentioned. Anxiety, more anxiety. Figures up to 80%, saying up to 80% of students suffer from statistics anxiety. And that can create certain problems. If I had £1 or $1 for every student that came to see me and said, I don't understand anything. I'm like, really? Nothing? No, don't understand anything. And then you sort of chip away at that a bit, and it turns out they actually understand quite a lot. But I think the anxiety just prevents them from realizing that there's a lot they have got. They're just maybe missing a few really important links that kind of make things coherent in their brain. Lack of motivation, potentially as a result of feeling anxious. But there's also stuff on the teaching side. So I've heard it said by some people that statistics is boring, which is people mad. I don't really know what other people's syllabi, whatever it is, are like, but certainly in the UK, I think until quite recently, there was a lot of similarity in the way that statistics was taught and the kind of curriculum that people had. And it's basically based on history. We're kind of like suffocated by the crushing weight of history because we tend to teach how we were taught and what we were taught. And when we come into our new place, we're like, oh, well, I'm going to teach statistics. Oh, I know, I'll teach it, how I was taught it. And, again, another message I would say is that you are better than the people that taught you, or you can be better than the people that taught you. Well, unless you're taught by me, obviously. I'm kidding. Expertise, I think that can be an issue. I've called it the curse of team teaching, which is a bit melodramatic. But I think it's really important to have consistency when you have, especially like where I work, there's, like I said, we have 600 students. So there's a big team of people, and we've worked very hard over the last few years to make sure we're kind of all on the same page about what we're telling students and all the rest of it. Also, the people that teach statistics are sometimes accused of being soulless, emotionless android cults. I'm sort of quoting my deputy head of school here. She calls us a cult. Admittedly, she hasn't said we're soulless and emotionless. But I think cult says it, right? You don't need the soulless, emotionless and android if you're calling part of your teaching team a cult, right? I don't know, maybe you do. But anyway, so, got to get over that culty image that we have. So does any of this actually stack up? Well, a few years ago, I did a report for the Higher Education Academy in the UK, which is like a big survey. It was across lots of disciplines, but I was like the psychology lead on it. So this is kind of illustrative of at least what people think. Like, don't get me wrong, this is not the greatest piece of research ever done or anything, but it illustrates some points, hopefully. So this chart is from higher education staff, about 80 of them, and they were just asked to endorse with, Likert scale, various questions. So the first question is about self-efficacy. You can basically see tons of them are saying students lack self-efficacy. So these numbers are the percentages of people endorsing, agreeing or strongly agreeing. Student anxiety, again, faculty agree it's an issue. Heterogeneity in the cohort, again, lots and lots of people agreeing that's a problem. It doesn't mean it is a problem, but at the very least, HE staff perceive it to be a problem. And in terms of the expectations, do students have realistic expectations about mathematics and statistics in their degree? Most people disagreed that they had realistic expectations. So from a staff point of view, they think, yeah, self-efficacy is low, anxiety is high, wide variability in students, and they don't have realistic expectations. So also on this survey, excuse me, here's the same staff, but also some students. So this is the question for students who struggle with quantitative methods, which factors typically inhibit their development? And again, there's a list of stuff kind of in order of how much they were endorsed. So maths and stats anxiety tops the poll for faculty. Then lack of confidence, failure to practice techniques, lack of numeracy skills, fear of formula, failure to seek help, lack of motivation. So basically, faculty are all in large numbers are endorsing things that are quite intrinsic to the student. If you look at the student side, which is the kind of orangey side, a lot of them are endorsing these things as well, but the percentage endorsing them is kind of quite a lot lower than faculty. But where there is a kind of semi-interesting difference is when you look here. So this is to do with the time elapsed since maths was studied. So in the UK, it's really typical that people study maths up to up to when they're 16. And in fact, that's a requirement of a lot of psychology degrees. But then they'll do another 2 years of things called A-levels. And it's not a requirement that they do maths A-level. So a lot of students have done maths up to 16 and then had sort of 2 years of no maths, and then they come into a psych degree. So the students are endorsing that as a problem much more than the faculty are. So the students are perhaps a little bit more focused on the extrinsic factors as a reason why they might struggle. So, it seems like some of these things that are floating around in the literature are backed up at least by the opinion of HE staff and students. Do students actually find stats difficult? A portion of them do, but I think it's worth remembering that that portion is the minority. So in this survey, about 40% were saying they found it either usually difficult or always difficult. So it's not at all the case that like the majority of students find it difficult, which I think is worth remembering because there's a lot of focus on how anxiety provoking it is and whatever, but it's like that is for a portion of students. It's not for the entire set of students. So some of the things on the teaching side, well, even a 2-year-old knows that statistics is boring. Zach, what do you think of Daddy's book? Enough said on that, I think. What about expertise? So that, is there a problem in our levels of expertise? I mean, hard to say and probably hugely variable, but there has been some research looking at the degree to which, people in academia understand statistical concepts who are not statisticians. This is a study by Haller and Krauss, which was replicating a study by Oakes from 1986. And basically, they presented people with 6 incorrect statements about what a p-value represents and asked people to endorse any of those statements that were correct. Now, the take home from this really is, if you look at students in this study, 100% of them endorsed at least one incorrect statement. So students are holding some misconception, like all students are holding misconceptions about the p-value. But this is not remotely surprising because if you look at the people teaching them, 80% of them also held at least one misconception about the p-value. And if you look at people doing research, about 90% of them have misconceptions about p-value. So there is a general sort of skills deficit. Is that the right way to put it? I don't, potentially. Just focusing on another study here. So this was, I don't know what I've done there. Just trying to get rid of that. This by Jeff Cumming, who is talking tomorrow, I think. It might be today, I don't know. So I won't dwell on this in case he also talks about it. But this was a really neat study from a few years back where they basically had a web applet and hang on. That's the thing I wanted. They had a web applet. So people were confronted with 2 confidence intervals, group 1 and group 2. And the group 2 one here, people could drag it up or down. And the purpose of the task that they were set was to drag that confidence interval for group 2 into the position where its overlap with group 1 represented a p-value of 0.05. So what we have here is kind of the results of that. So this point here is where they should have dragged the confidence interval to. That is the point of overlap where a p is 0.05. They computed what they regarded as a kind of a sensible margin of error. So anywhere between those dotted lines is seen as sort of an acceptable answer. So how many people actually got the answer within those acceptable limits? Well, the red stuff here is how many people got it wrong. So we've got a group of psychologists in the 3rd panel. In the last panel, a group of medics. And as you can see, there's a lot of red and not much grey. So most people, or a lot of people, got that pretty wrong. So arguably, we can up our, as scientists, we can up our game in terms of our statistical expertise. Okay, so what I was actually asked to talk about was what have I learned from teaching statistics? I mean, I thought that was going to be a really short talk, which is why I've had to pad it out with all this other stuff. You know, how do we change things? How do we overcome these barriers? You know, apparently I need to tell everyone the answers to everything, which of course I can't do. But I can tell you my general strategy, which is this.
I have no idea what I'm doing, but I know I'm doing it really, really well.
So, you know, having not really having a clue what I'm doing, I did think about some things that might be worth talking about. So here we have all the things that I just mentioned. So some of the problems we've got on the student side: heterogeneity, motivation, anxiety. I did them in like heavy metal logos because it felt like they ought to be like a, you know, kind of heavy metal festival of problems with heterogeneity as the headliner. And underneath that, we've got some of the things from the teaching side that are potentially problematic. And what sorts of things have I thought about? Not a lot, really. I'm going to talk about these in reverse order: differentiated learning, scaffolding, finding your voice, and encompassing all of those is reflection, 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 because that is probably the most useful thing you can actually do. So I'm going to talk about these in turn, but some of the things I'm going to talk about with differentiated learning is signposting and assessment. I'm not going to say very much on differentiated learning, to be honest, but we have been thinking about that a lot at Sussex recently. I'm going to talk a bit about scaffolding, so how I approach the curriculum that I teach. And then I think the most important thing, finding your voice, where I'm going to talk about some of the things that I do when I teach. But I'm not for a minute suggesting they're necessarily good things to do, but they are things that I do. So differentiated learning, I've inadvertently been doing this sort of in textbooks for kind of ages, because, I mean, not sort of, I mean, more by accident than design. So I always have these like little markers on sections in the book that kind of indicate how tricky I think they are. So, you know, a 1 bar is this sort of bread and butter stuff, and a 4 bar is like, whoo. But we've started introducing that a bit more in teaching, but it's always hugely sort of a problematic thing to do because of assessment, because it's kind of nice to have like a core curriculum and say, well, we can challenge the more able students with these kind of extracurricular things. But the reality is, at Sussex at least, that not many students do them. So there's a balancing act somewhere along the line, you know, between trying to have a sort of core curriculum that challenges everyone, but having enough stuff that challenges the more able students but doesn't lose the less able students. And I don't have a sensible answer of how to do that, which is why I'm going to skip over this really quickly. In terms of scaffolding, so I said about being crushed by the weight of history, and certainly the way I was taught statistics on my psych degree was using this kind of thing. I mean, ironically, this is from one of my textbooks, so I'm about to slag off these kind of flow charts. Like, they're terrible, aren't they? I mean, the whole idea of like teaching sort of 20 different tests, and every test has its own like set of assumptions and set of rules that you have to remember and all the rest of it. It's just basically really confusing. It's like, did I have chips last night for dinner? Yep, do a Mann-Whitney test then. Oh, but it was a Thursday, so you probably should have done a Pearson correlation. Chips and Thursdays don't go together very well. So, what I've been doing for a number of years, probably since about the 3rd edition of my SPSS book, is trying to structure things around the general linear model, which makes a lot more sense, and trying to kind of establish a set of core principles and core concepts that it's kind of like, if a student understands these things, then they kind of understand everything, sort of. So it's focusing their attention on kind of what, on a set of constructs that apply to more or less any statistical model they will fit. It has the acronym SPINE, the spine of statistics, and the concepts are sampling, variation, standard error, parameters, intervals, whether they're, you know, frequentist confidence intervals or Bayesian ones, null hypothesis, significance testing, estimation. So the way my curriculum is set up is, obviously your starting point is your scientific question. Then we talk a lot about sampling. So how, obviously we'd like ideally to answer questions using everyone that we're interested in generalizing to, but we can't. So we take samples and introduce the idea that samples vary. And so we need some kind of way to quantify the variability in statistics across samples. And that's what we use the standard error for. Having set that up, we talk about data visualization, but I didn't fit in with spine very well, really. I guess I could have had Spiven. I mean, you don't want the Spiven of statistics, do you? So we obviously talk about that a lot, but then everything is focused on just this one conceptual model, the general linear model. And it's like, well, this is going to be the same. All that's changing is the outcome variable might be categorical or it might be continuous. Your predictors might be categorical or continuous. But the framework of the model stays the same. Nothing is changing. So we've got a kind of a scaffold of information that doesn't change. And we can sort of look at variations on a theme. So any model we fit is going to have parameters that represent our effects. So if you understand parameters, you understand something about every model that you're ever going to fit. You can estimate parameters with a point estimate or an interval estimate. So if you understand about intervals, you understand something about any model that you're ever going to fit. And you can obviously tie that in with the standard error. So estimation is one thing. You might want to test those parameter estimates to see whether they're different from zero. So test whether your effects are different from zero. So their hypothesis testing comes in. So if you understand the idea of testing parameters against zero, then you understand something that applies to any frequentist model that you're ever going to fit. So you've got this set of kind of consistent principles that apply to any statistical model that you ever fit. And then you can start talking about what's going to kill your model. So you can start looking at things like outliers, like assumptions of the model or whatever. And some of these are specific to the GLM when you use ordinary least squares. But there are, again, some general, like inferential cases is, that's something you might want to think about beyond ordinary least squares. And then having done that, you can start talking about how you can resurrect any model that you ever fit by using robust models instead. So you can look at robust estimators, robust standard errors, bootstrapping, things like that, which again are principles that apply to pretty much any model that you might want to fit. So what you're doing is emphasizing the consistency rather than having like 25 different statistical tests that all seem unrelated to each other when in fact they're not. So this is kind of what we do. Incidentally, I noticed someone's giving a talk on robust stats. It might be later today, it might be tomorrow. Probably everything they're going to say, I agree with. We should definitely teach more robust stats. So finding your voice, this is an interesting one. So again, something that I introduced into textbooks really early on was a lot of kind of personal stories. I've got little life stories going on and all the rest of it. And, whether that's a good thing or not, I don't know. But so I use a lot of personalization, try to use engaging examples. I mean, as I get older, some of the examples I use do change a bit because well, they weren't very appropriate then, but they're probably, they're even less appropriate as I become an old, aging, middle-aged person. Always try to inject a bit of humor. I started using songs in lectures ages ago. And the sort of culmination of all of this, interestingly, I also have the acronym of SPINE. The sort of culmination of this was I've got this bee in my bonnet about trying to integrate statistical theory into narrative stories. And this was because in the SPSS book, I'd always like bookended all the chapters with these little stories from my life. So there's a little narrative going through it, but I always thought that was a bit rubbish. And it would be better if you could just actually have like a fictional story where the statistics is taught through an actual story. So you have a character who acts as the student. In my case, it was a person called Zach. Something happened. So basically his girlfriend is a brilliant scientist and she goes missing. And all he can find is some research report that she's written that he doesn't understand because he's a musician. And he sort of goes on this quest to try and find out where Alice is. And the only way that he can find this out is by unraveling what's in this research report. And to do that, he has to learn over the course of 800 pages a lot about statistics. So he learns statistics through meeting characters and interacting with the characters, and the characters act as the teachers and he acts as the student. And Well, here you go. Here's the sales pitch.
In a world driven by data, everyone needs a hero. He has arrived, a man to demystify statistics, a reluctant savior, a friend. He might just save us all. Join Zach Slade on his amazing journey to save his missing girlfriend, Alice, and learn about introductory statistics along the way. Help him survive the bridge of death, to fight the undead, to evade secret cults, and to piece together the jigsaw of recent events. Together you will conquer the enigma that is statistics. Start the adventure now. There is no time to lose.
Yeah, right. So it's a brilliant book. I mean, it's not. I like it. Not sure anyone else does. So a kind of extension of that was to bring narratives into lectures. So I now do a bunch of lectures where there's a story running through the lecture and I play characters in the story. So I'm going to give you some examples of these. There's a lecture on bias where I'm a wizard helping a young dragonling to stop a knight from killing all of the dragons. And the basic formula that I have is there's a setup, some kind of thing that needs addressing at the beginning. And then I am some character who addresses it using examples. Then there's normally a middle bit to kind of link the two halves of the lecture and to give students a bit of a break. And then at the end, there's some kind of resolution. So that the me in character is generally interacting with video on a screen. So I'm a wizard helping a dragonling to stop knights from killing all the dragons. And we've got various examples around whether you can predict various things like royalty kidnaps from the number of dragons in the area. There's another one where I'm helping a zombie to prove that zombies are scarier than werewolves. I do that around Halloween. I've got another one on repeated measures where I'm stopping an alien invasion. Actually, I did this especially for lockdown. I've actually got a serious headache of trying to work out how I'm going to actually do it live in a lecture theatre because I play about 15 different characters in it. But anyway, so I'm stopping an alien invasion of shape-shifting aliens using puppy sniffer dogs. And there's a logistic regression lecture that I do just before Christmas where I'm helping Santa to save Christmas. So here's like, oh, excuse me. Oh, everything's gone a bit weird. Sorry, I went a bit trigger happy with my mouse then. Where are we? All right, so here's an example of the setup for the wizard lecture.
Why have you come here?
Kill all the dragons, thank you.
Oh dear.
So in the lecture,
Oh dear,
I would
But
be like
dragons are
live.
nice. Why would you want
do the
to
video
kill them?
of my son?
Because they eat all your sheep. Because their dung doesn't help their crops to grow. Because they kidnap the princesses.
Oh dear, oh dear. Well, that all sounds a bit old-fashioned, kidnapping princesses. I'm sure they kidnap princes as well these days, you know.
They only kidnap princesses.
Anyway, what to do? I best talk to the dragons, see what they have to say.
Hey, can you help them? Can you stop from killing the dragons?
Well, I'll jolly well see what I can do.
And this is a clip from the alien one. This is the middle section. So I've already done an example and I'm segueing into a second example.
Days, you're back. Good news, the sniffer dogs did well. Although the results were not significant, the sample size was, pretty small, and the effect sizes are looking strong. I'm optimistic.
We have intercepted another transmission. It's more bad news, I'm afraid.
Oh no. Show me.
Laughing Dirt, mighty leader, I have returned.
Ah, Tunic Lane. How's the shape-shifting training going?
Exciting news! I can do the hands! Look! I've got human hands! But I'm having a bit of difficulty with the face now. I can't stop my face from being green.
Why are you here?
Ah, well.
And we'll finish off with a song,
Now
shall we,
it's
from a
time for
Christmas
Christmas
lecture.
song. Don't you agree, boys and girls? I thought so. Let's get to it. Yeah, it's coming to town. Yeah, it's coming to town. Logistic regression is coming to town. You better watch out, you might want to cry. You better beware, I'm telling you why. Logistic regression is coming to town. Santa's checking the output, he's checking it twice. He's gonna predict who's naughty or nice. Logistic regression is coming to town. He's got a binary outcome, residuals are normal, but with a logic log function, everything is cool. So there's nothing to fear, there's no need to cry. It's like every other model we've tried. Logistic regression is coming to town.
Right, enough of that. So yeah, reflection. That's kind of essential. There's 3 types, I think. The one I call ugly duckling reflection. This is what our institutions think is reflection, but I don't think it is. So this is like where you have module evaluation, questionnaires, and peer observation. And I think this is terrible, terrible, terrible idea. On the plus side, I guess you might get some expert feedback, but in general, it's just a bit hopeless. It's time limited, it's admin focused, and it creates the impression that, you get some feedback, you reflect on it, you write a little comment to tell everyone how you're going to do stuff differently, and then it's all done. I hate it. Reflection that I do is what I would call lab rat reflection. So this is like responding to the natural contingencies in your environment. So most of us, respond well to positive feedback and not so well to punishment. So if you're trying out something new, just, read the room. If you do an explanation, everyone's eyes are glazing over, then make yourself a note not to do it like that again. If the highly amusing joke that you thought was going to be a great idea results in tumbleweeds, maybe don't do it again, that sort of thing. I think the thing with this is write notes. So after every lecture I give, I always write myself notes about what I thought went well and what didn't, and put them in my productivity software to remind myself of things that I should do. And also tend to afterwards, if things haven't gone well, they will tick away in my brain. Have a lot of things happen in the shower for me. I'll be in the shower and I'll say, oh, that thing that didn't go well, I'll do it like that next year. So have a lot of showers. That always works. And of course, the other way you can reflect is to actually do some research, which is a massive time investment. And I guess a lot of us probably don't do, but we should probably do more of it. This is great because, obviously you're creating an evidence base for what works. Which moves me on to my next point. So this is the day about what works. I'm using narratives as an example of something I do. I could have picked other things like using humor or whatever. Does teaching me stories improve learning? So my current PhD student, Jenny, who was a master's student a few years ago, she did a master's project on something related to this. And this is a little summary of the studies that she found looking at this. We can immediately get rid of a load of them because they're theoretical. They're saying, well, using narratives should work, but there's no actual data in them. And then if you look at the rest, there's some from journals there where the source is J, it's journal, C is conference, B is book, and there's an unpublished one as well, somewhere down there. Basically, you've got a lot of stuff with no control conditions, no control courses. It's just like, oh, I did this thing, it seemed to work, but without comparing it to some other course that didn't do that thing. There's some pre-post designs. There's only sort of one. There's one experimental design with primary school children. It's all just really very, very non-conclusive. It might work. People think it should work, but we don't really know that it does. In our pilot study, we tried to take this kind of head on by doing proper randomization. We used some fictional narratives out of my textbook. We tried to create comparable materials that removed the sort of fictional story but kept the dialogue between characters. And then we tried to have a version that didn't have the dialogue between characters. So we had the same explanations, but not as sort of spoken conversations. And we looked at how students responded on 22 MCQs that measured the constructs in those textbook extracts. And the main thing we discovered is it's really hard to control teaching materials in that way. You know, we had lovely bits of the book, but trying to create sort of non-narrative versions of them, it's like, oh my God, because immediately you start ending up with different numbers of words and all these other sort of things that can confound your results. Anyway, but we would quite like to replicate this. We tried doing it last year and then COVID happened. So there you go. Does it work? I mean, I don't know whether I can tell you whether it works really from the data that we actually have, but there's kind of some sort of idea that maybe it's engaging to students, slightly funnier than to students, and maybe helps them visualize more. Who knows? That's in terms of like, well, they maybe like it. And I mean, a lot of the research is like, oh, I did this thing and students like it, but it doesn't tell us whether it actually helped them to learn anything. In terms of like the question of whether they learn anything, you know, there was kind of, we basically did a Bayesian analysis on this, and kind of at the group level, there's sort of a difference of about 2.5 points on our 22-point scale of MCQ, so not huge. And if you look at the HPD for that, it sort of suggests that at the worst plausible value of the effect is 0. It has no effect. And the best plausible value of the effect was about 5. So it could potentially make a difference on our scale of 22 of 5. But the sort of average was like 2.5. So, you know, I think this needs to replicate. I wouldn't base your career on this. I mean, I have based my career on it, but no one else should base their career on it. So this really illustrates the point that I kind of want to finish on in this final little section, which is we need to get better at doing research, because I'm not sure we actually know what works. I think we know what we think works for us, but I'm not sure we know what works in general. So we need a bit more joined up thinking about constructs. I'm going to use the example of maths and stats anxiety, which there's a big literature on maths anxiety, a big literature on stats anxiety that exists in a kind of void, but I just cannot get my head around why these things would be different. Like, I mean, statistics is just kind of a branch of mathematics. It doesn't make any sense to me that you could be maths anxious and not stats anxious, or vice versa. I mean, like, surely. But then people say, oh, but, you know, the measures don't correlate that strongly. But then you look at the measures and the items on them are just like asking about completely different things. You know, one of them's asking about, you know, asking questions, and one of them's asking about paying for pineapples. I don't know. And we don't have a lot of research that gets at causes. So, you know, where are the randomized control trials? I mean, if there are any, please tell me about them, because I'd love to know about them. Where's experimental work? Where are the people who are reflecting on their teaching by doing scientific experiments? So going on, I mentioned Jenny earlier on. This is Jenny. She's currently doing a project looking at this thing of like, is stats anxiety different from maths anxiety? And we started off by, because the stats anxiety measure that a lot of people use, the STARS, and the maths anxiety measure that's commonly used, I'm going to call it the MARS, the RMARS, the revised version. Because they're so different in terms of item content, we created modified versions. So we made a sort of version of the STARS where all the references to stats were changed to references to maths, and vice versa for the MARS. And the question is, can we discriminate people who are high on maths anxiety but low on stats anxiety, and vice versa? Because if they're different, you'd expect to be able to get some kind of discrimination. And we had just over 450 psych undergrads do this. And basically what Jenny found, we did a factor analysis, and what came out of that was 5 factors that were broadly around study and not specifically about maths or stats, one nonsense factor, And there were two factors, one that seemed to have stats items on it and one that seemed to have maths items on it. But actually, when we looked at them, it was more actually the stats items were about interpretation and the maths items were about numerical computation. So it may not be a maths stats thing in those two factors. And we also did a latent profile analysis. This is where we would be hoping to find clusters of people who are kind of high on one construct but low on the other. And we just didn't. It's like there's a group that are high on all versions of the questionnaires, low on all versions of the questionnaires, medium on all versions of the questionnaires, or low to medium on all versions of the question. It's like, it just does not seem like you can identify groups of people who are, high on maths anxiety, but low on stats and vice versa, which suggests maybe they're actually the same thing. And leading on from that, we were talking about this, and the conversation came up that our samples are kind of largely white middle-class English people, and wouldn't it be good to kind of replicate this and expand it a bit on a bigger sample? And I said to Jay, well, I could put out a tweet. We might get a few people wanting to sign up. 150 collaborators later, 45 countries, 25 different languages, and nearly 20,000 participants, I think. I say we, I mean Jenny. Let's not let me have any credit for this. I literally just sent the tweet. Jenny is now about to take over the world with this kind of extension of that project, which is just looking at, we're measuring lots and lots of different types of anxiety, but we're going to do a similar kind of thing, which is seeing like, can we discriminate the constructs of maths and stats anxiety when we factor in items from other anxiety measures and other things that people expect to be affected by maths anxiety. And a final plug for Jenny while I'm here is she has also set up a Researchers of Statistics Education Network. So for people teaching stats who are interested in doing research. So if that sounds like you, there's the URL there. So get in touch with Jenny. And like I said, my slides, there's a link to them somewhere. So you can just click the link in the slides. So the too long didn't listen. What works? I don't have a clue what works, but I'm not sure anyone does. So I don't feel too bad about it. But if anyone does, then let me know, because I'd love to know. Well, unless what works is not doing narratives, because I really don't want to give that up. We probably won't know what works until we do a bit more properly controlled research. And I really think we need to think a lot more about constructs than we do, especially things like maths and stats anxiety. I've mentioned Jenny. I also want to give a shout out to my other PhD student, Martina, who is also amazing, but does work that I couldn't shoehorn into a talk about stats teaching, but I don't want to leave her out because she's also fabulous. Other than that, thank you very much. And I'm happy to take any questions that anyone has.